Let us look at surface areas and volume of a cuboid. A cuboid is a three-dimensional figure which has length, breadth and height. How to find the volume of a cuboid? Let us look at the base, which is a rectangle with length L and breadth B. Let us stack this base h times. Now the volume of cuboid can be represented as the area of base multiplied by height, or L into B into H. Let us look at a problem. A box of cookies measures 10 cm by 5 cm by 4 cm. What will be the volume of a carton holding 12 such boxes? There are a lot of ways to arrange these 12 boxes. However, we only have to find the volume of a carton that could hold 12 boxes. So, I can simplify the volume of carton by multiplying the volume of one such box of cookies by 12, or 12 into volume of one box, which is length into breadth into height, which is 12 into 10 into 5 into 4, which is 2400 centimeter cube. Let us look at another problem. Find the cost of digging a trench of dimensions 15 meters by 4 meters by 2 meters at the rate of 50 rupees per meter cube. Now the trench is in the shape of a cuboid. So the cost of digging such a trench would be equal to rate multiplied by the volume of the trench, or 15 times L into B into H, or 15 times 15 multiplied by 4 multiplied by 2, 1800 rupees. Let us look at another problem. A godown measures 40 meters by 25 meters by 15 meters. Find the maximum number of wooden crates measuring 1.5 meters by 1.25 meters by 0.5 meters that can be stored in the godown. Now that is a huge godown. My volume is going to be L into B into H. Let us represent the dimensions by capital letters. So 40 multiplied by 25 multiplied by 15. Let us leave it like that. Now let us look at the volume of crate, L into B into H. Now since the crate is smaller, let us represent the dimensions by small letters, or 1.5 multiplied by 1.25 multiplied by 0.5 meter cube. Let us leave it like that. Now the number of crates that can be stored in this godown would be volume of godown divided by volume of crate. Capital L into capital V into capital H divided by small l into small b into small h. Let us substitute the values. Let us count the decimal places in the denominator. 1, 2, 3, 4. Now let us remove the decimals and multiply by as many tens in the numerator. So I get a 10,000 in the numerator. Now let us simplify. I am left with 8 multiplied by 2000, which is 16,000. So 16,000 crates can be stored in this godown. Let us recap. The volume of cuboid is L into B into H. How about the lateral surface area? The lateral surface area is represented by the walls of this cuboid. 2 times BH, which is these two rectangles, plus 2 times LH, which is these two rectangles. Take 2 and H common and write it as 2 times B plus L times H. How about the total surface area? That would also include the ceiling and floor of this cuboid. So lateral surface area plus 2 times LB. Let us substitute the value for lateral surface area. I can also write this by taking 2 common. So I have 2 times BH plus LH plus LB. Let us look at a problem. The dimensions of a room are 5 by 4 by 3 meters. What would be the cost of whitewashing the walls at the rate of 6 rupees per meter square? My room is in the shape of a cuboid. I am given the dimensions. Now I have to find the area of walls because I want to whitewash the walls. So I am looking at the lateral surface area of this room. So 2 times BH plus 2 times LH. Let us substitute the values and let us calculate. We get 54 meters square. So the area of walls is 54 meters square. Now let us find the cost of whitewashing. It will be area of walls multiplied by rate, or 54 times 6, which is 324 rupees. Let us look at another problem. A box of paint is enough to paint an area of 10 meters square. How many bricks of dimensions 5 by 10 by 2 centimeters can be painted? Please note, the paint is represented in meters square, whereas the brick is mentioned in centimeters. We would like to look at the surface area of the brick. Now since all 6 faces are going to be painted, we are looking at the total surface area, or 2 times LB plus BH plus LH. Let us substitute the values and calculate. We get 160 centimeters square as the surface area of a brick. Now the total paint available is 10 meters square. Let us convert this into centimeters square. So I get 1 followed by 5 zeros, or 1 lakh centimeters square. So the number of bricks that could be painted would be equal to total paint available divided by surface area of 1 brick. 1 lakh divided by 160. Upon simplification, we get 625. Let us look at another problem. A glass box of dimensions 25 by 30 by 15 centimeters is made from glass panes. The panes are joined together with tape along the edges. How much tape is required to hold the box together? However, we have to find out tape along the edges. We are not talking about volume or surface area here. Interesting. Let us show the hidden edges by dotted lines. Now let us count the edges. There are 4 L's, 4 B's and 4 H's. Now my tape required would be equal to the perimeter along these edges. which is 4 times L plus 4 times B plus 4 times H. Let us take 4 common and substitute the values. 280 centimeters.